here. Today we are in Autodesk PowerMill webinar on 2D machining. First, we move into our today's agenda. The first one is we are going to look into 3 examples. The first one is using a wireframe model. We are going to create toolpaths with the help of toolpath templates. The second one is actually it is a 3D model. Similar, we are going to extract the features within the 3D model and we will create a toolpath for that particular model. Then the third one is actually drilling toolpath, including chamfering and drilling operations. Then we will move into toolpath templates, how to create it and how to customize it. Then the final session is renaming of toolpaths and tools, because this was requested by some of the users. They are facing in renaming the toolpaths and tools. So the first we move into our first example is it's a 2D machining from using a wireframe model. The reason we are now moving into this wireframe model is actually it is not necessary to convert 3D model directly. We can use the wireframe model, start creating the toolpath. Also, we can opt cutter compensation option within this toolpath. The feature includes pocket, boss, slot, side face, and last chamfer and fillet. We straight away move into the first example. So this is our wireframe model. So I just created this wireframe model based on the requirement. We have in this model we have 4 guides at the 4 corners, and we have slot. Also, it is 4, and we had some 2 clamping pockets which is open, and we had also closed pocket. Within that we have 2 bosses included in 2 pockets either. So here I'm not going to use a regular toolpath creation, as we had already pre-created my templates. So I start using this. We are also recommending this using templates because it is very useful, easy, and it can be customizable actually. So the first one, we are going to start with extracting the features for guides at either corner, 4 corner. You start creating the feature group first. So you had created the first feature group. If you enter into the edit mode of the feature group, you can straight away, you can see the first one in the toolbar is detect feature, that is for 3D modeling. You can directly extract the features. The second one is actually, it is a milling tool feature creation, either from 2D or 3D. And the third one is actually, it's a turning feature creation. And there is some editing function within this toolbar. So the first one, as the guidebooks are open, pocket. So I use the side option first. In this particular feature creation, we had a wireframe modeling style of selection. So you just start selected the wireframe first. It automatically shows the direction of machining. So in this one particular case, I have to change the direction to the other way. For this particular guide bush, we have top and fillet radius is there. So I'm just using top fillet and bottom fillet with 5 mm radius in top and both. Just apply it. The next one, similar. You just start, the direction is okay. Just apply okay. Here the direction is different. You can change the direction by clicking the arrow mark. And similarly, at last we had the last guide bush. Once you are satisfied with the extraction of this guides, you just accept it. I'm not going to extract other features now because it is having different strategies. So I just accept. Once you accept, you can have these 4 machinable features. You can see directly. You can select all the machinable features by single click. As I told you, we are using toolpath templates. So I had predefined all my step over, step down tools, and even the cutting parameter of feed and speed are predefined. So straight away, I just go and calculate the toolpath. The usage of template is mainly for faster programming, and it is more accurate because it is already predefined. So if you see this, the toolpath is created for this particular 4 pockets. Open pocket, it's plunge well outside the job and move inside. The second one, I'm going to finish this particular 4 open pockets with the side finishing option. So if you see, I had selected feature finishing toolpath template with finishes. I had selected walls. You can go for either walls or flats, or together walls and flats. So for this particular case, I'm choosing walls and predefine my cut depth, everything. So I just calculate the toolpath here. You can similarly create your toolpath, what I am doing, which is more accurate, and you can reuse it within your shop floor, which is standard for every users. You can take the output in a similar fashion. That templates includes the lead and links functionality also. Okay, so if you go into the toolpath here, I had created a 2-way path, so you can see there is no jumpings within the toolpath. Even you can configure with it within the templates all those functionality. So the next one within this guidebook, I'm going to finish with the bottom finishing. So as I told you, it is predefined. I selected as a flats here and just calculate the toolpath. As you can see, this toolpath, it is plunged well outside the block or part and moving inside smoothly. So within this feature, I had completed roughing and finishing. Let's move into slots. So for that, I'm using a slot template, which is already predefined. So go to the feature, create a new feature group, enter into the edit mode, and select the slot function. Now here you can mention where your line is presenting within the slot. So here for this particular case, it is at the center. So just draw a line from the center of the slot and just extend it well outside, so that the tool will plunge well outside the path and move inside the job. So here, if you click this, select this line, you can see the way of flow. So now it is in opposite direction. I want to plunge from outside and to move inside. So just right click and say reverse. So I'm happy with that toolpath way. Then you just mirror all those this wireframe for all 4 other corners. So I'm just using a mirror function here. Just press YZ and XZ plane. You can see it is mirrored in all 4 slots. If you finished, you can just click and Now you can see that slot feature is created. That slot feature is now, it is almost 10 mm. So I just use a 10 mm width slot and just say apply for all slots together. Once you are fine, you just select again all the machinable features. You can noticeable here, it is selected 4 of 4 machinable features are selected. So as I pre-created all my cutting parameters, just say calculated. If you see this toolpath here, you can right click over this, simulate from start. It will plunge outside the job and it will move inside smoothly. So either you can give large depth of cuts if you wish. I had given here just 0.2 as my depth of cut. So in this fashion, it will complete. So the next one, we are moving to pockets. So for that, I have pocket roofing, toolpath template, which is a feature area clearance. Go into your feature page, create another new group and enter into the edit mode. Straight away, you can go into your pocket feature. Under that, you can find a freeform pocket. Select all your wireframe pocket. Just if you need to change your depth, you can change it here. Just say apply. And again, as there is a boss included within the pocket, similarly, you select the boss function here. Select the wireframe. If you just rotate, and you can notice that the boss is protrude outside the pocket. So what you have to do is just change your curve position as top, so it move inside the pocket. If you satisfied, just apply and select the similar way of the next boss and say it is lying on the top and just apply it. So I missed one pocket here, sorry. So if you're satisfied with this, the inside pockets, let's move to the side feature here. Here, you just pick your curves. And for this particular open pocket, there is no fillet. So you change back to your type to sharp corner. If you're satisfied with the depth, just apply it. Similarly, you just click this one. For in this pocket, it is showing it the opposite direction of the machining area. So just click by changing the arrow mark, then apply it. So I had completed all the pockets here. So I'm satisfied here, complete everything, and just select all the machinable feature. With the predefined parameter, I just say calculate. As you can notice here, even it is a wireframe modeling, the PowerMill will enter into the pocket for the closed pocket in the ramping format, and for the open pocket, it will plunge outside the part and it will move inside. So next we will move into finishing operation of those pockets. So I have a pocket side. In this particular pocket, we are using a cutter compensation on. This is why we are opting 2D machining particularly. The main reason of switching to choosing 2D programming is, first one is you can choose cutter compensation option. The second one is, as we see the slot feature, we can create the toolpath at the center line, and mostly we can use also for chamfer and fillet. It is more reliable than 3D model. So I had predefined with the parameter, I had switch on my cutter compensation on. So for this particular toolpath, I'm going to deselect these two clamping pockets, which is not so accurate. So just calculate with this inside pockets. As I told you earlier, I had predefined my lead and links even within the toolpath. If you see into their lead in page, it had given horizontal arc. So if you are not choosing this particular one, you can see a message warning will come and it will say that this toolpath is not suitable for cutter compensation output. So I'm going to roll back it to horizontal arc. Just copy into your lead out also. Just apply, accept. To make sure your the 2D cutter compensation is active, you just go into your toolpath page, come under display. You can see a compensated path. You can draw it. You can see that it is fine. You can start from 0.1 diameter. The toolpath I had used is inside the toolpath is 10 mm, so you can play around within the tools in your while doing your machining. So similarly, I move into the next one. I have a pocket for side that we are moving into the clamping area. So I just use a toggle option. So it automatically selects the rest of the pockets. For this particular toolpath, I'm not going to use a cutter compensation because it's open tolerance. So just calculate the toolpath. You can see similarly from the top view, the tool plunge well outside the part and it is moving inside smoothly. Finally, we are going to finish the bottom of all the 4 pockets. So select the bottom pocket option. So in this one, as I told you, it is a flats, machine flats only. Go to your feature page, select all your machinable feature and say calculate. As you can see, all the bottom flats has been machined clearly. Finally, we will move into the chamfer, which is the last operation in this particular model, which is very simple. Go to your feature page again, create a new feature group, edit into your feature group page. Now, within this 2D wireframe, I'm going to create a wireframe for creating chamfer. It starts from rectangular boss, free from rectangular boss. Enter into the curve editor mode. Just draw a rectangle across the insert and draw a composite curve. Just track it, those clamping areas. Just switch off your wireframe. Trim which is where it's not necessary. So this is the chamfer curve. So just tick by accepting it. Switch on the wireframe again. Now it is that the boss is coming up. So what you have to do is just say my curve is on the top. So you just move it a little bit down and go back to our fillet page. Say I have chamfer at the top and my dimension is 1 mm and say apply. You can see closely a chamfer is created in the boss. So once you're satisfied with this, you just select that boss feature. And here I had used a tapered spherical tool with 45-degree and 16 mm as my diameter. Let's start calculating the tool path. It will come in this fashion. It smoothly enter here. I will show in a simulation, 2D simulation here. Just well plunge outside. If you come into the front face, you can notice that the chamfer is created in the tool path here. Just move along. It's very fast to create this particular kind of chamfer toolpath if you are using 2D machining option. So I just show a simulation faster here. I just switch off all my tools, feature group, everything. Just create a ANSI program here. Move all your toolpaths within this ANSI program. Just apply it. I just recalculate my block for simulation. Start the toolpath simulation from simulate from start button. Enter into your simulation mode. Change your mode to rotatable and your shading as rainbow. Switch off even your wireframe. Now you just play your toolpath. As you know from PowerMill 2018, during simulation you can even rotate, zoom, can be taken place with quality of rendering. So you can see the simulation is completed. You can see that chamfer takes place in very well in all the corners. Okay, so let's move to the next example here. So what we are going to use is a 3D model. So we are imposing 2D machining within that. So mostly people ask what is meant by 2.5D. Here is the definition. Actually, what it works is actually it will work in 2 axes at a time, though it is having 3 axes. That is the actual definition for this 2.5D. The advantages of using 3D model uh, for using 2D machining is you can even go check as we have 3D model while creating the toolpath. Also, we have all 3 dimensions are available, readily available, so we can extract the feature without entering manually in Z direction, and also we can opt cutter compensation within the 3D model. So let's move into the second example here. For this, as I told you, I'm going to use templates. So here within this model, you can notice that there is a pocket with a boss and we get circular pocket, and we have 2 open pocket with chamfer and a slot of dimension 10 mm and a single hole where I'm going to use helical milling option. So I'd start with the corner radius. We have 4 corners with a fillet of 25 mm. So I use this particular corner radius toolpath template to finish it. So go to your feature page, create your feature group first, enter into the edit mode. Now you can see there is an option called new from 2019. There is a side feature extraction is there. Select your side feature, change your selection mode to surface from wireframe, select your corner radius. Now, if you see this, it extracted until the chamfer end. So what you have to do is just drag this arrow mark and place it over the top surface. I'm not going to impose chamfer within the fillet because I'm going to create the chamfer all around. So I just leave it as it is. Similarly, you just extract it, just move it, apply. It is very fast, you can do it. Once you are satisfied, just click By accepting, then select your machinable feature and say calculate. If you see within this tool path, I just close my feature group here. The toolpath takes in this format. There is no jumping within the toolpath segment. It is continuous movement. It is any direction milling. If you see the statistics of this particular toolpath, only 4 jumps within the toolpath. So also it is very easy to create a corner filleting in this fashion. So the next I am going to move to the slot machining, similar like 2D, but here create a new feature group and enter into the edit mode. In this particular case, we do not have any center line to create the slot, so it is not necessary to be have at the center line. You can select left or right of the wireframe lying. So here I'm selecting left, enter into the wireframe mode, just draw a line here. Select the line, just extend both ends 15 mm to plunge the tool well outside the path. Select the limit point option, select both and just say 15 mm extended both side and accept it. If you see this, immediately you can have that slot feature just by dragging the slot snap points. You can just have your length and width or depth with the 3D model. So I'm just happy with this. Just apply it, accept it, select the machinable feature, calculate. Now, if you see this tool path, go to the simulate. It starts from one end, but when it moves to the other end, it jumps at the air and then it is moving to the other end. So it is wasting of time. So what you have to do is just right click over the tool path, go to the edit mode, go to the reorder function, just click over automatic reorder and reverse. And if you see now, the tool path is continuously in action. There is no lift within the tool path. If you see the statistics, there is only one lift within the tool path. So let's move into our pocket machining again. Just I'm going to extract the pocket roofing first. Create new feature group, enter into the feature group edit mode. Now, I'm not going to use any one of the standard features. I'm going to select detect feature option. In this, we have 3 modes. One is single, and you have hierarchy and similar. If you select single, you can select this particular cylindrical pocket with chamfer together. So just say accept for this particular one. So the next one, we are going to select hierarchy. If you see, just if you move into the pocket, it automatically selects the child feature also. In this case, if you select single, it will be different. Pocket and boss will comes in different format. So what I'm doing is just select hierarchy, move into the pocket, select and accept it. The last one we are going to do is side. So select the side, change your either you can choose the surface option or you can detect the feature from here itself by using a similar function, similar mode. So if you just move into your feature, it automatically detects whichever is similar. So I just happy with this, just accept. Now you select all your machinable feature and just say calculate. So as I told you earlier, the PowerMill automatically detects the closed pockets, then it does ramping action, and wherever it is open, it is plunge outside the part. So the next one, we are moving into side finishing for those pockets. Similarly, I'm not going to machine for this particular toolpath uh, for this two feature. So you can deselect it from here. So you select this particular feature only. So for this particular pocket, I'm going to use cutter compensation option. Just calculate the toolpath for side finishing and move into your side finishing for the rest of the pockets, open tolerance. Just toggle select and just say calculate. So now for the bottom finishing, I'm going to select all the features together, but I'm going to give some stock for the side walls because I already finished it. I don't want the tool to be rubbed while doing bottom finishing. Just say calculate again. So you can see it plunge well outside and finish the bottom. Finally, we will move the chamfering option for this particular model. We had chamfer here. The toolpath template is readily available. Go to the feature page, select a new feature group, go into the edit mode. Now, if you select a freeform pocket, instead of going into the regular edit curve, you straight away move into the composite curve page. Just drag over your chamfer. Once comes, you can jump it from one end to another by selecting the point. Just go straight without any tangential point and just move it again from there. And finally, you come to this point and close the curve and just say save. Once you're satisfied, you just click and say your curve is on the top. If you see this, that boss feature is created from the bottom of the chamfer. Just drag your arrow mark over the surface, go to your fillet page, say my top chamfer is 1 mm, apply. You can see it is exactly matched with the 3D model. Accept it, select the feature, calculate. As you can see, by using the templates, we can finish the part in less than 5 to 10 minutes by using a 2D option. We had opt cutter compensation even within the toolpath. We had chosen the chamfer in this model. So finally we move into our whole feature, so which is not under feature group. So what you have to do is create a whole option here, select the whole and just say apply. In this particular case, if you see this whole, it is come from bottom side. So what you have to do is just reverse the whole by moving into our edit page. Go to the toolpath template page, we have option called helical milling. Select the feature with the predefined values. I just say calculate. Here I had used a helical option. So if you see the tool path, it starts from center of the hole, and the continuous action takes place at the end. Again, it moves to the center and come up. So finally, we move into the third example here, which is a drilling tool path, which includes all the drilling operations like boring, reaming, rigid tapping, helical milling, thread milling, including external and internal. The whole selection, that means filter option, is available for diameter, depth. You can, based on color, you can select the hole, draft angle, hole type, and level. Let's move into our third example here. With this particular model, I start with doing a corner machining for all the 4 corners. There's an option called, we had a ready-made template is available for corner chamfering. Select OK. Go to the feature page, create new feature, go to the edit mode, select the side face feature, change your mode to surface, select your surface. Satisfied, just apply it. Apply for the 4 corners. Come back to your normal position, accept it, select all your machinable feature, and just say calculate. As you can see, that side face feature is much helpful in creating this kind of tool paths. You can see here it's plunged outside the tool from the path and it is moving inside. Also, if you see the tool path, the continuous action is there. If you see the statistics of the tool path, it is only you have 4 lift for the 4 segment of the tool path. Let's move into our hole creation. So select your hole model, right click over your hole feature set, just say create holes. From you have a 3D model, you create all the holes from the model. If you have any other option, you can choose from here. By selecting group hole by axis option, just move into creation of the holes. So either if you want, you can have the edit after creation. So that after create that whole feature set created, you can edit the holes also. So just for time being, I just switch off it. If you apply it, you can see this. If you see under that whole feature set, it was created in 4 different directions. So you can see here the first one from the top, the second one from this way, and for either side of the part. If you notice the second one, some of the features has adopted from the bottom. So it is purposely done to show how to move this particular feature to the top level. So you just select all the holes, right click over the holes, go to the edit page, say reverse selected. So what it will do, it will automatically move to the particular layer. It's to move to the first one now. If you see these holes, it is that the top chamfer and that bottom hole is compound hole. So what I have to do is just select that holes. You can right click over the hole, just say separate compound holes. So what you have to do is actually you can see this bottom hole and chamfer get separated. So now we will start moving, creating the toolpath. I start from center till here. As a predefined template, single pick for my center till. I had choose operation as center till. Here we had different operations. You can either go to hole depth or full diameter. You can choose through hole if it is. Now for this particular case, I'm choose center till option. I've chosen 5 mm as my depth. And if you see defined by where I have to start plunging the tool, I said it is from the block. So if you see the two part, I'm going to machine I'm going to drill the tool paths after milling operation. So it is already cut these areas. So I'm going to start this one. If you are not done the milling operation here, you can say you can block. If you've done that milling, you can say whole top. So straight away it will move into the height of the plane. So for this particular case, as I completed my milling operation, I had select whole top. So go to the selection page. Here we have selection mode. As I told you earlier, we have different kind of filters available. For this particular case, I'm using a diameter option. Choose the diameter from the feature set. So here I have 6.5 hole selected. So the next one is 8 mm. So here, then we will move to the 12 mm hole, which is inside the counter bore, and we will move to the 16 mm hole also. So I'm going to leave these particular 4 holes because I'm going to use an U drill to do the operation. Just close this and just say calculate. If you see this toolpath from the sidewise, as I selected whole top, it moves directly to the particular plane and starts plunging. The next one, I move to the 6.75 holes. Go to the select page with a predefined tool selection. Cancel all your selection filter. You select only 6.5 holes and just say calculate. Either you can opt single pick or you can select deep drill operation. For this particular case, in that case, you have to give the peg depth. For this case, I had given 3 mm. So just calculate. If you see this tool path, simulate from start, it will move inside the toolpath in this fashion. It start picking from the top if you select the block option. So it start from here if you had not done the milling operation. So I just move back to the settings again, refresh your toolpath, and now change your back to your whole top option, and you just say calculate. You can see now all the toolpaths plunging starts just above the hole. So I just continue with other holes, just say 8 mm hole, using a deep drilling option, clear the selection, move your 8 mm drill. If you would like to do the pre-drilling for 12 and 16, you can do it. Just move into this one. I had missed this particular hole for selecting compound hole. So just reselect again, close the feature, and just say calculate. So if you see straight away, actually you can see a red mark here because this particular 12 mm hole is blind hole. But what we had given in the particular operation is actually it's a through hole operation. So just change back to your full diameter. So that is the main advantage of the drilling operation using 3D model. You can straight away check whether it is gouging takes place or not. Similarly, you can select 12 mm drill with the pre-selected template. Just change your 12 mm drill and calculate. Similarly, you can go for 16. It's very fast. You can create your drilling toolpaths. So the next one, I'm going to move into counterbore. So for this, I am going to use helical milling option. So I had used here helical milling as selected cycle type. So select those particular 4 holes. It's a 20 mm diameter, and just say with the pitch of 0.2, I just say calculate. So similarly, you can do this for U-drill operation and boring. I just skip from here to move into our slide, as it is similar kind of operation. Back to your slide. So as we had seen how the toolpath template helps you to do the programming, it is really fast, and as I told you, it is predefined parameters, so it is standard across your shop floor. So different programmers get the same output and for the toolpath operation. As it is approved toolpath, it is error free. So if you choose the template, what are the things you have to be considered? Actually, each and every parameter can be skipped or you can include it. If you just go back to your either one of your example, you right click over the toolpath template and just save as strategy. Likewise, you can create the template. If everything is proved within this toolpath, you just say save as strategy, and it automatically move into a particular folder. If you would like to change, you can change it. You just say go and save. In this particular one, you can just say test or whatever the name you would like to do. You can give and you can save it and use it back those templates while doing toolpath creation. I'm going to do it again to show some more advanced feature. If you would like to skip some of the parameters, you can select this named selected parameters only. So under this, if you don't like any feature to be included within the template, you can skip it. Either lead and links or tool axis or feed and speed, you don't want to be included, you can skip it. So likewise, you can create the templates. So back to your template. I think I had finished with this toolpath template and what are the advantages over it. The final, we move into renaming of toolpaths and tools using macro. So many of the users, they had requested this particular macro to show in this webinar because they are programmers are making mistakes while naming the toolpath or renaming the toolpath. Which includes that but this particular macro includes sequence number, type of operation, and type of cutter and tool diameter, including tip radius. So it is fast and accurate because no error going to take place with the diameter or sequence number or type of tool, and then it is error free, so it can be customizable. If you would like to receive this macro, kindly contact your local application engineer team. They will get the information from you to customize, and we will send through them. Just we will move into one of the example here, and we will run the template here. So if you see here, I just go and run the toolpath renaming. So just I'm having a toolpath renaming macro. If you just say okay, it will ask you only one thing. It is actually whether you what type of operation it is. You may give different names for different companies. So what you have to do is, for this particular case, I'm just showing CHM underscore corner. So once click, you can notice that that rename has take place. So you have sequence number, you have the type of toolpath you had mentioned before, and the type of tool and the diameter with radius, tip radius if it is. So similarly, as you just move into other tool paths, you just say center drill. So just say center. You would like to do it, automatically it comes the renaming of tool path. The next, all those drilling tool paths are simple. So I no need to be enter any name. So just I going to skip it just by entering the underscore. So you can see this toolpath naming. It's very fast and accurate. Similarly, you can have the macro for the tools renaming, which is mostly happened in our shop floor. We enter the diameter of the tool inside, maybe different, and that naming will be different. So for this particular one, I had created this macro. Within a matter of second, you can rename the tool path and tools. If you see this, but for this particular case, it's an end mill type and the diameter is 20 mm. If there is no tip radius, it is 0, 0. So we will move to the another example also. Let us see how the toolpath again it works. Just I'm going to run this macro, toolpath running macro. Toolpath renaming. It will ask you what type of operation. Just say corner underscore fillet. So it is a slot. So it is a pocket roughing. It's a side, pocket side. So open pocket side. Then bottom feature. Then chamfer underscore mill. Then hole feature. You can mention the diameter of the hole even. Likewise, you can complete the toolpath naming. It's very fast and accurate. So let's move into our slide again. So if you would like to receive this macro, as I said earlier, contact your local application